In this question, a ball of mass 2 kilos falls vertically onto horizontal ground. Before impact, velocity is minus 10 in the j direction, minus 10 in the j direction in meters per second, and the coefficient of restitution E is 3/5. Find its velocity after impact. Well, we're going to get 3/5 of 10. If you want to do it the simple way, that's going to be equal to 6. It's going to go back up, so it's plus 6j, the velocity immediately after impact. The impulse imparted to the ball, impulse is going to be its mass times the velocity afterwards minus the mass times the velocity beforehand. So we have 2 here for the mass times the velocity afterwards is 6j, and then we have minus 2 times the velocity before, which is minus 10j. So you can see here we're going to get 12j plus 20j, so the impulse is 32 joules. 32 in the j direction in Newton seconds. Then on to the loss in kinetic energy. So half mu squared, what's the change here? So a half times 2 times this 10, or this minus 10, to be technically correct to be squared, is going to give 100. And afterwards we have a half times 2 times the 6 squared, which is 36. So 100 minus 36 is 64 joules for the loss in kinetic energy for question 1 in this section. Question 2 covers the same kind of thing. Coming down straight, speed of 20, coefficient of restitution is 0.5. So it's coming down, so it's going minus 20 in the j direction. Coefficient of restitution is given as a decimal, so we call it minus a half. For E when or E is a half, we call it minus a half when we're putting in our after over before is equal to minus E. So 2x is 20. So we're going back up in the j direction, positive 10j. We're asked for the magnitude of the impulse or the speed immediately after impact. So speed V is equal to 10 meters per second for the speed. And the magnitude of the impulse, so impulse is equal to mass times velocity minus mass times previous velocity, 0.2 times a velocity that we finished with of 10 minus 0.2 times the velocity we started with, which was minus 20. A fifth of 10 is 2, and a fifth of 20 is 4, so the impulse is going to be 6 in Newton seconds. And the loss in kinetic energy, so my half mu squared is going to be a half times, well, I'll put it in as a fraction just to keep it consistent. 1 over 5 is 0.2, a half m by u squared, so this is afterwards is 10, so 10 squared minus a half by the mass of a fifth by the velocity beforehand, which was 20, or minus 20 to be squared. You want to put the minus in, so we're going to get 100 divided by 10, which is 10, and we're going to get 400 divided by 10, which is 40. I have these strong way around. This is 40, so it's going to be 40. Draw the line after minus before, which is 30 for the loss in kinetic energy of the ball. Measured in joules. Go to number 3. In this question, the mass is 1 kilogram. It's dropped from rest. We have u equals 0. A height of 2.5. If we need s is 2.5. And coefficient of restitution E is equal to 4 over 7. And we're asked for speed just before impact. So we're looking for V is equal to, we have U, we have S, and we have A is equal to gravity, which is bringing it down. So we can use V squared is equal to U squared plus 2AS. So V squared is equal to 0 plus 2G by 2.5. This one comes up a lot. 5G is 49. V is equal to 7 meters per second just before impact. its speed just after impact. So the new speed over the old speed, well, is it coming down directly down? So it's going to be minus again. -7 is equal to minus e, which is -4/7. You could leave out the minuses. You can see here the x is going to be 4. 7x is 28. X is equal to 4. So the speed just after impact is 4 meters per second, positively bouncing back up. The impulse imparted to the ball, impulse v minus mu for impulse, and we're talking about the mass being 1 times the velocity afterwards being 4 minus the mass of 1 and the velocity beforehand being 7. And just tag in your minuses so you get your 4 plus 7 to be 11. That's J. I should have my J's in there in Newton seconds. And the loss in kinetic energy, so my half mu squared again. So before is equal to a half times 1 times the velocity squared, so it's going to be -7 to be squared, so it's going to be 49/2 or 24.5, and after a half times 1 times 4 squared, so it's going to be 8, so 24.5 minus 8, a loss of 16.5 measured in joules.